Okay, today I'm going to do presentation on multiplexers and others. So a multiplexer is a combinational circuit that selects one of many input lines and forwards it to a single output line. It is being applied in data routing, in CPUs, memory addressing, communication systems, specifically serial to parallel communication. So So now we move to others. Others perform binary addition. A binary addition is one of the core operations in ALUs, which is the arithmetic logic unit. There are three main types of adders. We have the half adders, we have full adders, we have ripple carry adders. So a half adder is a logical circuit that takes in input of two 1 bit and gives an output of two 1 bit as the sum and carry terms. Full adders full adders then they take in an input of three 1 bit and produces an output of 1 bit as the sum and carry terms. Ripple carry adder, so it is constructed by connecting full adders in series. The carry the carry out or the carry output of the full adder becomes the carry input of the next one. So it just works like the real life case of the ripple. So when you drop a stone into water, you can find a ripple in it. The current moves from its initial point and becomes the next ring around the point where maybe the stone was dropped. So it moves, then another wave is being formed following it like that. So the first one's output becomes the first one's input. Yes. So these are diagrams that shows how they are. So with the full adder, we have the three 1 bit inputs. We have the input A, input B, and then carry inputs. And then we have the sum of it, and then the carry output over here. So the full adder accepts three 1 bit input, maybe numbers, let's say numbers, and then gives two output, which is the sum and then the carry output. And then the half adder accept two 1 bit inputs, which is the A and B here. If it can be a num it can let's say a number. So it accepts this and then gives an output, two output, which is the sum and then the carry as output over here. Now with the ripple, we have three full adders over here. We have four of them, one, two, three, and four, labeled FA0, FA1, FA2, and FA3. So the carry output, which is a C3 of FA3, becomes an input for FA2 over here. And then C2, which is the carry output of FA2, becomes the input for FA1, and then the C1 here is the output for FA1, but here it becomes an input for FA0. So this is a a diagram to show the application of the adders and then the multiplexer. So this is a multiplexer over here. So out of many inputs over here, the multiplexer will accept one input at a time, and is being controlled the by this side here. So this is what to determine what input it should accept over here. So right now here it is being labeled 00, which means the is being labeled here 00, which means that with this let's say at this side it is going to pick the first value over here. So it's going to pick the first one over here. If it was to be 01, it will pick the middle one here, and if it was to be 10, it will pick the last one over here. So since it is 00, probably it's going to pick this side. So the OR gate here, with OR gates you need only one input, at least one input, to get an active output. At least one active input to get an active output. So since the inputs here are not active for the OR gate, their output will also not be active. So probably this is also going to be 00, and the 00 here, with the 00, the multiplexer here is going to pick the first line over here, which is actually inactive. So the output here also be 0, which is inactive. This is inactive because this line is actually inactive because of this side over here. We have an XOR gate and an AND gate over here. With the XOR gate, you need at least one input to be true to get a true output. If both inputs are true, the output will become false. So the input here to the XOR gate is 0, and the input here is 1. So since it is only one input that is active and the two are not active, the output will be active. And then the AND gate here shares an input with the input B here, which goes to the XOR. So it will the AND gate needs both input to be true for the output to also be true or active. So since it is only one, the output is going to be 0 over here. And also, since the carry input here is also active, and an XOR gate to give an inactive output when the two inputs are active. Since because of this, the output is inactive, so this side becomes inactive. Hence, the output here also becomes inactive. So with this AND gate over here, both inputs are active. So the output will become active, and the OR gate here needs at least one input to make it to make the output also active. So since only one input is active, one input is at least one input is active, the output here will also be active.